Bismillahirrahmanirrahim. Assalamu alaikum. I'm Fakhr Lodi and this is our 20th lecture of Formal Methods for Software Engineering. In the last lecture, we started to discuss Object Constraint Language. As we discussed in that lecture, Object Constraint Language is an extension of Design by Contract, and it has been adopted by UML, and now it is part of the UML standard. UML, as you know, is now the de facto standard for de facto standard notation for specifying object-oriented models. Object Constraint Language जो UML में है, its scope is much more than the design by contract. In the design by contract, we just had the pre and post conditions for methods and the class invariants. Now in a model, since we have a number of classes and those classes, they are linked and they are related with other classes, and they collaborate with other classes to achieve the work that is supposed to be done. Hence, we need a mechanism that would cover not just one class, but the entire model. And in the model, as we know, it has a static aspect as well as a dynamic aspect. So we can have dynamic models, we can have static models. So this object constraint language covers the entire spectrum of UML, covers both the static models as well as the dynamic models. इसमें जो चीज़ ख़ास तौर पे हमने पिछले लेक्चर में देखी थी, it was not just the pre and post condition for the methods in a class and the class invariants, but also we could have invariants for attributes, we could have invariants for our associations, we could have the initial values, we could specify the initial values of attributes, we could specify the initial values for associations, we could specify the body of a method also, we could specify guards, जो कि हमने एग्जाम्पल देखी नहीं थी और ना ही हम उस डिटेल में जाएंगे, but I mentioned that you could have guards for state transition diagrams. So, बेशुमार चीजें ऑब्जेक्ट कंस्ट्रेंट लैंग्वेज के दायरे के अंदर आती हैं और ऑब्जेक्ट कंस्ट्रेंट लैंग्वेज उसको अहाता करती है. Now, all these different things, add a lot of value to the model. For example, we just talked about the initial values. Initial values, obviously, they are not invariants. They are initial values and they are supposed to be there only when the object is created or that link is established and so on and so forth. And hence, after, if you apply other methods and transactions and so on and so forth, वो initial value खत्म हो जाएगी. Initial value का scope सिर्फ जब instance की creation के वक्त है. But it is a very useful piece of information कि initially इसकी value होगी क्या. इसी तरीके से वो body जो है, it's a very useful piece of information. और उससे ज़्यादा जो सबसे इंटरेस्टिंग इसमें चीज़ जो है वो ये है कि आपकी जो एसोसिएशंस हैं, जो आपकी क्लासेस के दरमियान में जो रिलेशनशिप्स हैं, आप उन रिलेशनशिप्स पे सर्टेन कंस्ट्रेंट्स आप स्पेसिफाई कर सकते हैं और उन रिलेशनशिप्स पे जो कंस्ट्रेंट्स आप स्पेसिफाई करते हैं वो कंस्ट्रेंट्स जो हैं कई तरह की हो सकती हैं. उसमें हमने ये कहा कि ये इसकी फॉर एग्जाम्पल द नंबर ऑफ इंस्टेंसेस अगर वन टू मैनी रिलेशनशिप में है, द नंबर ऑफ इंस्टेंसेस will be less than 100 in one specific case. We saw that example. So this is one constraint then that we can impose. So आपका मॉडल तो है, वो तो सिर्फ आपको बताता है कि it can have many instances, but how many? Could it have 1,000,000 instances? The answer is no. So in that particular case, we have an upper limit. We can specify that upper limit. और ज्यादा इससे इंटरेस्टिंग जो चीज हमने देखी थी वो ये थी कि जब ये रिलेशनशिप्स जो आपकी मुख्तलिफ क्लासेस के दरमियान में जब आती हैं, अब कोई एक एट्रीब्यूट है क्लास का, एक तो इनवेरिएंट कंडीशन हम स्पेसिफाई कर सकते हैं, एंड दैट इनवेरिएंट कंडीशन एट्रीब्यूट पे जब हम स्पेसिफाई करेंगे तो एट दैट टाइम दैट मीन्स, and we specify it at the class level, that means all instances of that class, they must obey that invariant condition. So वो attribute की वो जो condition जो होगी, that must be fulfilled for all instances of that class. But interesting thing here is when we have associations, and we have class A which is associated with class B, and at the same time class A is associated with class C. So there are few instances of A which would be related with few instances of B, and some instances of A would be related with instance of C. And it is quite possible, and that is usually the case, that the instances of A which are related with B, they are not the same as the instances of A which are related with C. So there may be some kind of overlap, or it could be a totally, mutually exclusive set. And especially this will happen when you have aggregation and compositions. So आपकी association अगर aggregation और composition type की है, तो in that case, the instances, they have to be mutually exclusive. In the case of associations, there can be some overlap, जो non-aggregated kind of association है, जिसको हम regular association हम कह सकते हैं. Now, in those particular cases, what we are saying is that, instances that are related through this association, there is a condition imposed on those instances and certain attribute of those instances only. So we say those instances that will participate in this relationship, they will fulfill this particular constraint. And this constraint is not or may not be applicable on the other instances. If it were an invariant on the class level, then it would be applicable to all the instances. And here we say it is applicable to some instances. So ये एक बहुत powerful आपको tool मिल जाता है. इससे यानी कि बेशुमार आप सोच सकते हैं इसके फायदे हो सकते हैं. ये जो object constraint language है, it not only gives you a documentation tool, but it also provides this information that you can use to generate code. So जो आपके case tools हैं, जो आपके ये models को लेके code generate करते हैं, ये इन सारी चीजों को लेके वो code के बीच में build in कर सकते हैं. And make sure that those constraints जो आपने इधर model में लिखी हैं, उसके against code has been generated, because remember that this is a formal semantics. जब आपने इसको formally लिख दिया तो इसका code आप generate कर सकते हैं. It can be compiled. And you can provide the body of the method also. And अगर आपने वो model जो है मुख्तलिफ उसमें apply करना होगा, then you can see कि एक तो मुख्तलिफ लैंग्वेजेस के लिए कोड जनरेट करने में आसानी है. ऑल्सो यू कैन से कि ये बॉडी में ये चीज़ मैंने लिख दी गई है. अब जो मॉडल चेकर जो है, can also check if some constraint is violated or not. So at the design level, when you are doing this detailed design kind of activity and putting all those semantics into the model, at those time, it can be checked. और वो चेक करने से फायदा उसका क्या है कि you can catch errors and mistakes in your model quite early in your development phase, and hence the overall development cost can be reduced and the productivity can be increased. So ये सारे इसके फायदे हैं, and then you can develop better and components with high quality and so on and so forth. आज हम object constraint language की, let us look at some more examples and see how can we use it and how can it help us in developing better models. So these examples are simple examples. I'm going to show you examples with 1, 2, 3, 4 classes, so on and so forth. Relatively more complex than what we saw earlier on, but still, very simple example. But they tells you, and shows you the power. Like I mentioned earlier, unfortunately, we do not have time to go into the dynamic models and show how this object constraint language can be used in the dynamic model. But I think, the idea here is just to give you a flavor of OCL. So let us look at this very simple example and this very simple case. Here we have a simple model with 3 classes: the airplane, the flight, and the person. There is a one-to-many relationship between a plane and flight. So plane can obviously fly for many number of and can have many flights. And there is this person and flight, and there is many-to-many relationship between flight and person, passenger. We have in the airplane has an attribute that is the number of seats, and the flight has this method available seats, and so on and so forth. So an association between class flight and class person indicates that a certain group of persons are passengers on the flight and will have multiplicity many on the side of the person class. When you just look at this model, the model says the number of passengers is unlimited. In reality, the number of passengers will be restricted to the number of seats on the airplane that is associated with the flight. And that is under ordinary situation, when we are using the UML, simple UML, it is not possible to express this restriction. So here what we have seen is 3 classes: the plane, the flight, and the passenger, the person. And there is a many-to-many relationship between the flight and the person. And ये many-to-many relationship जो है, ordinarily when you look at this relationship, it shows that you can have any number of passengers. This is just many. And in this particular case, ये एक और यहाँ पर interesting चीज है, वो ये है कि आप you cannot give a number. For example, अगर आपके पास एक बड़ा जहाज है, if the plane has large capacity, शायद उस पे आपके पास 300 सीटें हों. अगर आपके पास एक छोटा जहाज है तो शायद उसमें 50 सीटें हों. So you cannot put a constraint between the flight and the person. You cannot say the number of persons is not going to be more than 50 or more than 300. अगर आप 50 रखते हैं तो इसका मतलब ये है कि जहाँ पर 300 वाला जहाज है वहाँ पर ये कंस्ट्रेंट आप वायलेट करेंगे, वो उसकी कैपेसिटी फुलफिल नहीं होगी. ऑन दी अदर हैंड अगर आप इसे 300 रखते हैं तो जहाँ पर 50 सीटों वाला जहाज है तो वहाँ पर अगर 300 पैसेंजर आ गए तो ऑब्वियसली वी हैव अ प्रॉब्लम. सो वी नीड टू हैव सम काइंड ऑफ अ मैकेनिज्म टू specify this particular constraint. Now what we need to do is we need to get information from the plane and then use that information to specify the number of passengers. And how can we do that? With the help of OCL, we can easily do that, and here is the constraint. So what we do is we put the context flight, so it is within the context of flight. The invariant is passengers size is less than equal to plane dot number of seats. आपने ये देखा कि इनवेरिएंट हमने पैसेंजर्स पे लगाया है और कंडीशन हमने प्लेन से उठाई है. पैसेंजर और प्लेन का डायरेक्ट रिलेशनशिप नहीं है, इट इज थ्रू दैट फ्लाइट. बट this OCL is such a powerful language that even if you do not have a direct relationship, you could still write those kind of conditions and make sure that that condition is not violated. And hence, ये आपने देखा कितनी आसानी से हमने वो प्रॉब्लम को सॉल्व कर लिया. यहाँ पर हम एक फिक्स कंडीशन नहीं दे सकते थे. तो जिस तरह का प्लेन है उसमें जितनी सीट्स हैं, जो उसमें एट्रीब्यूट दिया हुआ है, उसकी वैल्यू उठाई और उसको पैसेंजर्स पे हमने मैप कर दिया और हमने कहा कि पैसेंजर्स की जो इनवेरिएंट कंडीशन है, इट इज नॉट गोइंग टू बी ग्रेटर देन द नंबर ऑफ सीट्स अवेलेबल इन द प्लेन. हियर इज अनदर एग्जांपल. वी हैव these three classes: a person, a house, and a mortgage. There is one-to-many association between a person and house. So person would be the owner, and one person can own 0 or more houses. There is one-to-many relationship between a person and a mortgage. In this particular case, the person becomes a borrower and can have more than one mortgages or 0 or more mortgages. And there is one-to-many relationship between a house and a mortgage. In this particular case, now the house becomes the security and against mortgages. Now, seems like a very simple model, but there are certain constraints, certain restrictions that we must impose. So the first constraint could be, a person may have a mortgage on a house only if that house is owned by him or herself. One cannot obtain a mortgage on the house of one's neighbor or friend. The second condition could be, the start date of any mortgage must be before the end date. The third is, the ID card number of all persons must be unique. The fourth constraint is, a new mortgage will be allowed only when the person's income is sufficient. Fifth constraint is, a new mortgage will be allowed only when the counter value of the house is sufficient. So यहाँ पर हमने देखा कि we have once again a very simple model, only 3 classes here, and they are related in association. The person and the house, one-to-many relationship; person and mortgage, one-to-many relationship; and house and mortgage, one-to-many relationship. And there are different kinds of roles that these different classes will play here. Now, हमने मुख्तलिफ constraints पे बात की. What we want to have is in our model, and when you just look at this model, that's all it tells you. It doesn't say anything. There's nothing there. But obviously, इसके अंदर semantics नहीं है. ये एक बिल्कुल एक static सा, mute सा model है जो एक formal, ये तो आपको बता रहा है कि कौन सी किसके साथ related है, लेकिन उस relationship का मतलब क्या है और उस relationship पे कौन सी conditions हैं और ये काम कैसे करेगा system. ये एक mortgage का system है. So what we wanted to do was, we wanted to specify some business rules here. So the business rule is, for example here, कि जो घर mortgage किया जा रहा है वो आपका अपना है. You cannot mortgage somebody else's house. So जो आप बैंक को जाके आप pledge करेंगे या उसके mortgage लेंगे या कुछ करेंगे, you cannot do it for somebody else or by showing somebody else's property. It has to be your own. Similarly, जब ये mortgage की एप्लीकेशन होगी और मॉर्गेज की एप्लीकेशन अप्रूव होगी, उसके लिए सफिशिएंट इनकम की ज़रूरत है. मे बी has to have some qualification in terms of the income before a certain amount is approved. इसी तरीके से जो घर जिसके अगेंस्ट मॉर्गेज किया जा रहा है उसकी जो प्लेज करेंगे उसकी वैल्यू शुड बी सफिशिएंट. तो ये सारे आपके बिजनेस रूल्स हैं जो हम ये मॉर्गेज की एप्लीकेशन में हम डालना चाहते हैं. UML का मॉडल does not talk about those rules, but we can add those rules with the help of object constraint language. Let us look at those rules. Let us look at those constraints that can be used to specify these rules. So the first is context mortgage. Invariant security dot owner is equal to borrower. ये पहला जो रूल जो है, पहली कंस्ट्रेंट आप ये क्या कह रही है? इट इज सिंपली सेइंग दैट द बोरोअर इज द एक्चुअल ओनर ऑफ द प्रॉपर्टी एंड दैट इज व्हाट वी वांटेड. अब यानी कि आपने मॉर्गेज पर्सन एंड द हाउस जो दैट वाज प्लेज्ड और जिसके अगेंस्ट मॉर्गेज लिया जा रहा था, इन तीनों को आपने इस रूल में इकट्ठा कर दिया. What is the next rule? Once again, the context is mortgage. The start date, invariant start date is less than end date. Once again, this is a very simple rule, but once again, very useful one. Here, what we are saying is that this invariant must be fulfilled कि start date उसकी end date से कम नहीं हो सकती. But that was a straightforward, simple thing. The third is context person. Invariant person, all instances is unique ID card number. Now, once again, what we wanted was, we wanted कि जब भी उसका instance बने person का, हर unique instance must be for a unique person. Different ID card होगा. ये नहीं होगा कि एक ID card के against दो instances बन जाएंगे, एक ही बंदे के दो इंस्टेंसेस बन जाएंगे. सो यहां पर हमने उसकी ऑब्जेक्ट क्रिएशन पे हमने रिस्ट्रिक्शन लगा दी कि ये ऑब्जेक्ट क्रिएट ही नहीं होगा अगर ऑलरेडी उसी आईडी कार्ड का नंबर का एक इंस्टेंस पहले से मौजूद है. सो वंस अगेन अ वेरी यूजफुल थिंग. कई बार आपको इस तरह की चीज करने की जरूरत पड़ती है, बट हियर वी कैन डू दैट विद द हेल्प ऑफ this object constraint language. Next is context person, get mortgage, some money, security house. Precondition for that is self mortgage dot monthly payment sum is less than equal to self salary multiplied by 0.3. So here once again हमारा रूल क्या था? What we wanted to do was कि मॉर्गेज का जो अमाउंट है उसकी इनकम के साथ कोई रिलेशनशिप होनी चाहिए, सैलरी के साथ कोई रिलेशनशिप होनी चाहिए. एंड वी हैव टू जज कि ये सैलरी से जो रिलेशनशिप जो है, सैलरी की सर्टेन परसेंटेज, इन दिस पर्टिकुलर केस वी सेड 30% ऑफ द सैलरी से, यानी कि आपकी कम होनी चाहिए जो अमाउंट आप उसकी मंथली जो पेमेंट करेंगे या जैसे भी करेंगे. और अगर ये नंबर उससे ज्यादा बनता है तो इसका मतलब ये है कि द पर्सन विल हैव डिफिकल्टी इन पेइंग द मॉर्गेज एंड हेंस जो उस मॉर्गेज को अप्रूव नहीं करना चाहिए, जिसको आपको पता हो कि अल्टीमेटली द पर्सन विल नॉट बी एबल टू पे. सो हियर हमने ये कह दिया है कि उसकी सैलरी जो वंस अगेन जो हमारी एक कंडीशन थी, यहां पर हमने इसको डिफाइन कर दिया विद द हेल्प ऑफ दिस OCL. एंड फाइनली वी हैव दिस कॉन्टेक्स्ट पर्सन, गेट मॉर्गेज, सम मनी, सिक्योरिटी हाउस. These are the parameters. So the precondition is security dot value is greater than equal to security dot mortgage dot principal sum. We are saying here once again without going into the syntax, यहाँ पर मेरा syntax में जाने का मतलब नहीं है, and I did not want to bog you down with the syntactic details, although you can very easily make sense out of the syntax, but you know, object constraint language का syntax पढ़ाना यहाँ पर मतलब नहीं है. You can probably very easily learn it yourself, and please do that. But here, you know, the idea really is that, you know, what we are doing is we are saying that जो mortgage की जो value थी वो जिस property के against है उसकी value के साथ उसकी क्या ताल्लुक है. And in that particular case, we are saying that it should be, you know, less than or equal to what has been pledged. So point once again is कि आपने ये देखा कि although इन constraints को लिखना ज़्यादा मुश्किल नहीं है. These are business rules that could have been very easily written, and they are very easily written. But now what you have done is you have added those business rules into your model, और अब जो है बड़ी आसानी से ये जो भी पढ़ने वाला है उसे पता है कि इस मॉडल का क्या मतलब है. When those are added as nodes, as constraints, you know, it is part of the model. You can look at it and then you can make sense out of it, and hence the model becomes more robust. So ये इसमें सारी इसकी चीजें. Now let us look at a more a bigger example in which we have a little bit more number of classes. 4-5 classes में होंगी. अभी तक हम 2-3 classes तक देख रहे हैं. Once again, कोई ज़्यादा फ़र्क चीज़ों का नहीं है, लेकिन I just wanted to show you more concrete examples so that you can have a better idea of what this object constraint language is really. So let us look at this new example. In this example, we have these classes, and we have a course, we have a school, we have a instructor, and we have students. And there are relationships here between these classes. A school has a number of courses, so there is one-to-many relationship between school and a course. A course has number of prerequisite courses, so a course may have 0 or more prerequisite courses, so there is an association from course to itself. Then there is a relationship between course and instructor. An instructor can be teaching a number of courses, and then there is course and student, so there may be a number of students in a course. So there are some simple kind of constraints that you may want to impose. For example, if you had a constraint on a student that their GPA must always be higher than 2.0, you can attach that constraint to the student context, and it will become self.gpa is greater than 2.0. So this is a straightforward, simple thing. But you know, you must remember that if you want to allow a GPA of less than 2 and send out a letter to the student's parent in the event such a low GPA is achieved, you would model such behavior using UML diagram such as an activity or interaction diagram. Another very simple constraint is salary of instructor is greater than 0, so you say self.instructor.salary is greater than 0. So this is once again a simple kind of thing, and so forth. So यहाँ पर हमने देखा कि ये 4 classes थी और इनकी आपस में relationship है. Those relationships are normal, just like the examples that we saw earlier. उससे बहुत मिलती जुलती हैं. Only thing is it's a different problem and different model, और इसमें associations are different. और इसमें जो constraints जो हैं ये उसी तरीके से जिस तरीके से हम पहले दिखा चुके हैं. बेसिक constraints उस तरीके से लग सकती हैं जिस तरीके से GPA of a student, salary of a teacher, and so forth. सो कोई इसमें खास ज्यादा फर्क नहीं है. लेट अस लुक एट सम ऑपरेशंस, जो जरा थोड़ी सी ज्यादा कॉम्प्लिकेटेड एग्जांपल्स होगी. सो ऑपरेशंस पे कंस्ट्रेंट्स हम कैसे लगाएंगे? ऑपरेशंस आपके मेथड्स और इस तरह की चीजें जो हैं, जो आप एक्चुअली यू विल बी एक्चुअली परफॉर्मिंग, उन पे जो कंस्ट्रेंट्स लगेंगी वो किस तरीके से लगेंगी? ऑल्दो वी हैव सीन सम एग्जांपल्स previously, but let us look at examples in this particular case also. So here is a problem. What we want to do is, we want to make sure, once again a business rule, that any student who will be registered for a course has paid their tuition. How do we specify that? We say course, registered student, S is the student that we are talking about, and this is going to return Boolean, and the precondition for that is S dot tuition paid is equal to true. So once again हमने एक constraint इस पे कर दी कि जो भी स्टूडेंट रजिस्टर होगा क्लास में, रजिस्टर होने से पहले ये चीज चेक होगी कि उसकी ट्यूशन पे होगी. So this is a precondition. It must be checked. It will be checked before the student is registered into a course. So ये आप देखें कि एक आसानी आपको मिल गई, एक बिजनेस रूल वहां पर दे दिया गया और वो बिजनेस रूल आपने लिख दिया, and it can be very easily code can be generated and the condition can be checked. Let us look at some more examples. We can use the keyword result in the post condition. So in this case, we want to verify that a student's tuition was paid before registering for a course and that the operation registered student returned true. So we want to give a complete definition for this registered student method. So in this particular case, we have this precondition, that is tuition paid is equal to true, and the post condition, that is result is true. So यहां पर हमने देखा कि उसी मेथड के लिए एक ही कॉन्टेक्स्ट के साथ हमने प्री एंड पोस्ट कंडीशंस दोनों लिख दी, and we have completed the specification for that method in that sense that now we not just have the precondition but also the post condition. कोई फर्क ज़ाहिर नहीं है देखने में जो आपके डिजाइन बाय कॉन्ट्रैक्ट की केस थी, बट just showing how can we do it with the help of OCL. Let us look at another example. Now we can also have invariants. So we can name precondition and postcondition by placing a label after the pre and postcondition keyword. So the precondition, now we give it a label, has paid tuition, and postcondition, student has registered. So we give this precondition a name and we give this postcondition a name, and this can be used in our invariant conditions. So here once again बड़ी इंटरेस्टिंग सी चीज है, गो थोड़ी सी इसमें सिंटैक्टिक डिटेल आ जाती है लेकिन फ्लेक्सिबिलिटी भी है. When you are writing a precondition and when you are writing a postcondition, you can give it a name, and when you give it a name, that name can be used in other expressions. So ये बड़ी एक इंटरेस्टिंग यहाँ पर केस है OCL का. The postcondition can use the at pre keyword to refer to the values of some elements before an operation executes. So here is this example where we ensure that a student was registered and that the number of students in the course has increased by 1. So what we do is we say context course registered student वो method. So pre is S tuition paid is equal to true, and the post condition is result is equal to true, and self students is equal to self students at pre plus 1. ये जो at pre है ये हमारा डिजाइन बाय कॉन्ट्रैक्ट में हम जो वो ओल्ड देख रहे थे, दिस इज व्हाट दैट इज. सो एट प्री का मतलब ये है कि प्री से पहले क्या चीज है. अच्छा, यहां पर एक इंटरेस्टिंग चीज है, ओल्ड जो था वो पूरा एक उस इंस्टेंस के बारे में बात कर रहा था. नाउ हियर वी कैन टॉक अबाउट इंडिविजुअल एट्रीब्यूट्स. सो एक इंस्टेंस है, उसके 10 एट्रीब्यूट्स हो सकते हैं, बट वी आर ओनली इंटरेस्टेड इन वन एट्रीब्यूट. सो वी आर नॉट क्रिएटिंग द एंटायर instance and keeping a clone of that and keeping an instance of that, but here we are just maintaining that particular attribute and its old value that we need. So ye ek, once again, it's a useful concept. We can specify results of a query operation using the keyword body. Remember that OCL doesn't have a syntax for program flow, and we are limited to relatively simple expressions. So here is an expression that indicates that the honor students are students with GPA higher than 3.5. The collection syntax used here basically shows that. So we have the context, course, get honor students, and body is self.students select GPA is greater than 3.5. So in this particular case, this query, once again, this is a rule, and we are saying that an honor student, for example, the university has this rule that if a student has a GPA of 3.5 or more, he or she will be declared as an honor student. So जब a student graduates with GPA of 3.5 or more, so हम कहेंगे कि honor student है. Well, very easily we can specify that in the body, and that will return, this is a query, returns a collection, it will return a number of students there. So आप ये देख रहे हैं कि OCL आपको कितना powerful mechanism provide कर रही है to specify not just the constraints but also business rules. यानी कि एक तरीके से ये basically it is a constraint. But this constraint actually is giving you a business rule, and अगर आपके पास अच्छा tool मौजूद है, so ये business rule can be easily, the code can be generated. So ये बहुत बड़ा इसमें advantage है कि आपने specification में अपने business rules लिखती हैं. So आपने code के बीच में जाके आपको business rules को code करने की जरूरत नहीं पड़ रही. जब आप model बना रहे हैं, उस वक्त अपने business rules आपने लिखती हैं. OCL also supports conditionals. It supports basic Boolean expression evaluation using the if then else and end if keywords. So the conditions are used only to determine which expression is evaluated. They can't be used to influence the underlying system or affect program flow. So this is not for program flow. This is only to कि कौन सा expression करना है. And here is this example where this invariant enforces that the student's year of graduation is valid only if he or she had paid her tuition. So we say context student invariant. If tuition paid is equal to true, then year of graduation is equal to, let's say, 2005. Else year of graduation is 00, which is not really specified, and if. So here we are saying that in this particular case we are specifying a rule that year of graduation is a valid year of graduation. 000 is not a valid year of graduation only if the student has paid the dues. Now once again, this is a very big language. इसमें बहुत कुछ है. Actually अगर आप इसका reference manual आप लेंगे, and it is freely available from OMG's website. It is www.omg.org, और वहाँ पर जाके आप object constraint language का इस वक्त version 2.0 is available. You can download it as a PDF file and you can have it and read it. It's a big manual. So there are a number of things. But here, one thing that I wanted to show was that, you can have the if then else conditions, and then those if then else conditions basically are used to specify which condition will be applicable, which constraint will be checked. ये program flow की नहीं है. Remember that this is just a model checker. Object constraint language ये model पे है, ये program flow की हम बात नहीं कर रहे. So इस चीज को ज़हन में रखना चाहिए कि this is not program flow, this is just constraint checking and which particular constraint is or should be applied. The rules for OCL logic are that when we have a true which is odd with anything else, it is true. When false is ANDed with anything else is false. We have false implies anything which is true. Here we have, this is how we can use this implication. The example is, what we want to enforce is that if a student's GPA is less than 1.0, his or her year of graduation is set to be 0. If the GPA is higher than 1.0, rule number 3 applies and the entire expression is evaluated as true. And rule number 3 is this implication, meaning that the invariant is valid. So here is how we are going to write it. Context student invariant, self dot GPA is less than 1.0 implies self dot year of graduation is equal to 00. Now once again, ये आपने ये देखा कि in the case of OCL, we can use implication. So we say कि ये है implies this, and when it is false, it is always true. And when it is true, obviously the right hand side of the implication has to be true. But otherwise, if it is false, उस केस में हमें राइट हैंड साइड के लिए वरी करने की जरूरत ही नहीं, जो बेसिक इम्प्लीकेशन जो हमारा इम्प्लीकेशन लॉजिक है. बट हियर द इम्प्लाइज इज अ कीवर्ड इन OCL and can be used easily to develop and specify these kind of rules. OCL supports several complex constructs you can use to make your constraints more expressive and easier to write. So here is this example. You can declare a variable by giving it a name followed by a semicolon, which will be its type and the expression, and then can use it. So here is this example. In this example, we declare an expression that ensures that a teacher of high level course has appropriate salary. So we say context course invariant, let salary colon float is equal to self.instructor.salary in. So here we have defined a variable salary. So now we use this salary. So if self.course level is greater than, let's say 4,000, whatever that number is, then salary is greater than 100,000, else salary is less than 100,000, and if. Now here we have seen that in OCL we can define variables, and these variables can be used in our constraints. So like I said earlier, like I have been talking about, that this is a complete language जो इससे पहले हम डिज़ाइन बाय कॉन्ट्रैक्ट हम दे चुके हैं और जे कॉन्ट्रैक्टर वगैरह को हमने देखा था, वहाँ पर द स्कोप वाज लिमिटेड और वो बहुत छोटी सी चीज़ थी रिलेटिवली स्पीकिंग. हियर इट इज़ मच मोर कॉम्प्लेक्स एंड इट कवर्स अ लॉट ऑफ थिंग्स. सो इसका सिंटैक्स और इसकी सिमेंटिक्स काफ़ी रिच है और इसमें बहुत कुछ आप कर सकते हैं. बट रिमेंबर दैट दिस इज़ नॉट अ प्रोग्रामिंग लैंग्वेज. ऑल्दो इसका सिंटैक्स फॉर्मल है, प्रोग्रामिंग लैंग्वेज की तरह का है, बट इट इज़ नॉट अ प्रोग्रामिंग लैंग्वेज. ये जो आप वेरिएबल्स डिफाइन करते हैं और इस तरह की चीज़ें करते हैं, ये आप इसलिए कर रहे हैं कि यू कैन यूज दोज टू reduce the complexity of your expression and you can build those expressions systematically. एक ज़्यादा complex expression है, उसको तोड़ के छोटे छोटे expressions में variables में value डाल के और फिर उन values को आप आगे इस्तेमाल कर सकते हैं. But it is not a programming language, it is a specification language. ये important चीज़ है to remember and note. There is a difference between a specification language and a programming language, and there are similarities among those. One may argue कि एक जो आपकी प्रोग्रामिंग लैंग्वेज है, फॉर एग्जांपल C++ में आपने कोई कोड लिखा है, what does that mean? Somebody may say कि it is the specification of what the programmer wants to do. Of course, that is true. So from that point of view, this is also a specification language, but this is not an executable language. It will not give you any results. So this is the basic difference. जो programming language जो है वो आप execute करके उसको result करते हैं, but this language will not give you many results. But it is a very powerful, very complex, but very flexible language, and you can specify a lot with the help of this language. So ये object constraint language हमने देखी. Although we did not go into the details, इसमें बहुत सारी चीज़ें हैं जिसमें जिस चीज़ को हमने बिल्कुल टच नहीं किया वो उसके डायनामिक मॉडल का एस्पेक्ट है और उसमें कंस्ट्रेंट्स की डेफिनेशन एंड सो फोर्थ. बट आई जस्ट वांटेड टू शो यू कि ये जो फॉर्मल टेक्निक्स जो थी वो आहिस्ता आहिस्ता मेन स्ट्रीम डेवलपमेंट के टूल्स में आनी शुरू हो गई हैं. ऑल्दो दिस इज़ नॉट अ कंप्लीटली फॉर्मल थिंग, it is a semi-formal kind of activity. इसमें यानी कि वो उसमें फॉर्मल वेरिफिकेशन जिस तरीके से हम पहले हम देख चुके हैं वो इसमें नहीं है अभी तक. वो हम मेच्योरिटी लेवल हमारे टूल्स का वहाँ तक नहीं पहुँचा है. ऑल्दो पीपल आर ट्राइंग एंड आई होप कि वन डे इट विल बी देयर. लेकिन उससे जो पहला स्टेज है वो अब मेन स्ट्रीम डेवलपमेंट एक्टिविटी में आना शुरू हो गया है. ऑब्जेक्ट कंस्ट्रेंट लैंग्वेज, जैसा कि मैं पहले कह चुका हूँ, इट्स अ बिग लैंग्वेज. उसमें बहुत सारी चीज़ें हैं डिस्कस करने वाली, बट अनफॉर्चुनेटली वी डू नॉट हैव टाइम. यहाँ पर मेरा मकसद ऑब्जेक्ट कंस्ट्रेंट लैंग्वेज को बताने का सिर्फ इतना था कि दिस इज़ अ वेरी यूजफुल टूल विच इज़ कमिंग इन द मेन स्ट्रीम डेवलपमेंट, एंड द सॉफ्टवेयर इंजीनियर्स should be aware of this tool, and the tool is based upon the formal techniques. So formal methods की एक एप्लीकेशन है. मैं अपनी गुफ्तगू को ऑन ऑब्जेक्ट कंस्ट्रेंट लैंग्वेज इसी जगह पे ख़त्म करूँगा और अगले लेक्चर में आई विल बी टॉकिंग अबाउट अ न्यू फॉर्मल मेथड और फॉर्मल स्पेसिफिकेशन लैंग्वेज, और सेट ऑफ लैंग्वेजेस और बेसिकली अ ब्रॉड टेक्निक, and that technique is known as algebraic specifications. So मेरी डिज़ाइन बाय कॉन्ट्रैक्ट पे जो डिस्कशन है वो अब ख़त्म होती है. मुझे आप इजाज़त दीजिए. अगले लेक्चर तक के लिए खुदा हाफिज़ और अस्सलाम वालेकुम.